There are a few more seats in front, if any of you want to come in. Anyway, hi, my name is Kripa. I work in the SRE division in Google. I've been, well, it's kind of a bit of an ominous start. I also work in cloud, but this is not about cloud, so we're going to talk strictly about the stuff I'm actually talking about. But I've started this a bit ominously, in that I actually haven't been in Google 10 years. Just around there, almost there. It sounded cooler to say 10 years than 9.7. But so I've been there a while, and I think I've been on this the disaster recovery testing effort in Google for as long as I can remember. I've been part of it since I don't know when. But this is ominous for a second reason, which is that long ago at school, one of my professors told me that well begun is half copied. So how many of you were at Mikey's keynote yesterday? Most of you? So I liberally copied, I was very inspired by his stuff, so I liberally copied his pyramid scheme that he thought was just a diagram, but I love it. So I took it and I actually rewrote my entire slide deck overnight, last night. So I've got a lot of Mikey in there somewhere, so we'll talk more about it as we go along. So if you guys remember, the reason this was awesome to me was because a lot of the concepts he went over, I could plug in directly into the stuff I was talking about today. So I actually drew a digital version. Maybe I'll ship this to him. So here I am. My world is basically the bottom four. I think this was the order, because I didn't take notes while he was doing the talk, but basically monitoring incident response, postmortems, root cause analysis, and testing really is where I'm going with this. That's what most of my organization works on, and therefore, thank you, Mikey. But let's talk a little bit further about this. In any average team, this is sort of like the standard set of operations, right? The teams set a bunch of thresholds, they monitor a bunch of things, they get paged, and then they fix it, and then they write a postmortem. And then usually at that point, you get tired. You have bugs, maybe the big ones you get fixed immediately so no one sees any issues anymore. The older ones just languish, sometimes for days, months, years. And then, by the time you get to constant testing, this is totally someone else's problem. This is nobody really cares about. So this is what an average team might look like. I mean, some better, some not so much better. So yeah, we have that. However, if you look at a company the size of Google, any large organization, actually, it doesn't have to be the size of Google, any large organization, this pyramid kind of looks, oh, sorry. Our team was actually brought in to take care of the testing bit, which is what the rest of the presentation was about. And the goal was to prove if Google could actually survive a disaster. And yeah, the general response is, of course we can. We'll see how far we got with that in a second. But generally, if this is the pattern that you see in most organizations, this is really what an organization looks like. It's not like the one beautiful pyramid. Every team has its own pyramid. Do you already see a problem with this picture? I'm pretty sure you do, but we'll talk about it again when we get a bit closer. So that's what I work on. This is the job that we have at hand. So we were brought in to do the whole testing bit, and in Google this is called DIRT, disaster recovery testing. Yeah, thank you. So what this basically is that we have multiple days. This is an annual exercise, or used to be an annual exercise, where we have multiple days where we actually trigger failures in our systems. And by system, I actually mean, technology, people, process, whatever we want to break, we break. The premise back in the day, and it still is kind of the premise, but we've altered it a little bit, is a 30-day incapacitation of headquarters. And the reason we said that was because Mountain View, California at the time, our headquarters, was the largest body of people who were single points of failure. We had a lot of data center space nearby. We had a lot of issues that could happen from just taking Mountain View off. But now we have offices everywhere, and we have different sort of like nuggets of knowledge everywhere. We also have data centers everywhere, and it's not like the same footprint exists in every single data center. So anything that goes down actually has a whole slew of issues that are not consistent with something else going down. So now we have 30 days of incapacitation of whatever it is that we feel like taking down. So that's what we do usually every year during DIRT. It literally is something where hundreds of engineers, in fact more I think, are participating, whether it's in the ops land, whether it's in SWE and testing. We also have a lot of business functions, so our people ops divisions or finance and physical security, all of them are generally involved. It's a super fun exercise for those few days in a year. We write maybe hundreds, if not, depending, a lot of people don't even tell us what they do. So the hundreds and hundreds of tests come out of this every year. But let me actually make the last bullet is probably what's important over here. Our team, we are responsible for making sure the whole event runs, but there are two types of testing that happens during this time. Our team writes disasters. What we mean by that is we don't write tests that are confined to one team or one service or one infrastructure piece. It has a splash effect. If I pull the plug on whatever it is that I'm pulling the plug on, it will affect more than one service. All of the teams that we're talking about also write their own tests, but they're a little bit more scoped down in the sense that their tests are usually going to be something that they can fix within the scope of their own teams. So ads write something, ads should be able to fix the something more or less, or maybe one or two extra teams, but if I go and say I'm unplugging X data center, it means everybody in that data center is going to get affected. That's sort of the distinction between the tests we make happen to people versus the tests they make happen to themselves. But the impact is still there. All of this happens in production, which generally means, or most of these happen in production, which generally means this has very, very high potential to cause user-facing issues. And it has, and I will never admit to it if you ask me what they were. So things absolutely do go wrong. So there are a couple of things we have to set straight before we get any further. The first one is that when you're in the middle of this dirt week, days, whatever, some number of days now, we have to monitor via every single channel possible to know what's actually going on. First of all, you need to know whether it's you who's causing something or if it's actually a real outage that the service is causing themselves, because they're both happening in production. And if this means I have to monitor Twitter to find out what's going on, we will do that. So we have a war room that's got 900 dashboards of everything possible under the sun, because it's really, really hard to isolate what exactly the splash effect is going to be, depending on the test you create. The second is we absolutely need to have a way to roll back. I want to explain this a little bit. It's very hard for us when we design these disasters to actually test it. I mean, unless our test environment is an exact replica of production and has the exact set of services that production has by unplugging that thing, we actually don't have a test environment. So we can go as far as to say, hey, if I want to cause a fiber cut, and I'm going to create this set of config files that are going to isolate the fiber, the network in this manner, I can test that that config file works. But I can't actually test what will happen ahead of time. So all of this actually gets rolled out for the first time in production. So hopefully it'll work. And if it doesn't, we absolutely need a way to roll the config change back so that people don't see what the impact of this actually is going to be. So that's super important. And the third part is we need an incredible amount of prompt response and communication. This is both my favorite and my least favorite bit about the DIRT exercise. The favorite bit is because if you're in a war room, you get to be the recipient of the bat phone. Everybody calls you, you know what's going on all the time, everybody tells you, fix this thing, and we'll go fix it, it's great. And we don't want it to, but the problem is we've created an artificial escalation path. In real life, we don't exist, right? In real life, we want people to escalate to whoever they're supposed to escalate to, not to the people that are causing them more pain. So I love this part of the exercise, but I really do think that we're creating an artificial bit that I wish we haven't solved for it yet, so just leaving it out there. So let's talk a little bit more about the evolution. So I've done a few talks before on this in FlowCon or SRECon and such. So I'm not really going to go into the super details of how the logistics in DIRT, just how far we've progressed in the time that we've come here. So let's start with the first year of DIRT. This is the year that I wasn't really fully engaged. I was sort of like a recipient of it, really, and the people who worked on this never wanted to come back to it. That's how I adopted the project the next year. That's sort of, they leave me alone. So, but the first year, this was extremely tabletop exercise sort of thing. So teams would test each other. It's all theoretical. They would go over, hey, here's a use case of an outage I had. Let's all, as a team, work together to figure out how we could have debugged this better. Could the outage response time have been shorter? So they'd walk through this, but there's actually no technical content that went into it. I mean, actual demo content that went into it. Everything was done on paper. That was great and all, but by the time a lot of people were just angry because it was boring, they said this is pointless in the next year. So the next year, we said, let's take this one tiny notch further. And the following year, we said, let's bring down our source control. And not because we wanted to bring it down just for the fun of it. We'd never actually failed it over before. So if we did lose it, we would really lose a lot of things at Google. So this was several years ago, but I have a story around this. When you bring down something actively for the first time, this is fundamentally opposed to everything that every SRE is built to do. They're trying to bring this up, and we're saying, no, we're going to keep this down. Someone else is going to bring this up. So it was a really, really hard position for us to be in. So there were some engineers we made really, really upset. There was one that was really mean and was yelling at me the entire time, and it was all, this is not a drill, you need to bring the system back up. I mean, no, this is working exactly as intended. The system should be down, and we're going back and forth. But what I didn't realize was that I have this whole war room of people, and the war rooms on IRC, we have sister war rooms in Dublin, Sydney, I don't know, a couple other offices, and I'm hoping one of them would back me up. Anyone say anything to this person? But no, this is what was going on. They actually had a betting match in Sydney as to who will win in a boxing ring if the two of us went at it. So So my war room didn't really work as intended at the time. So anyway, that was what happened. But at the time, we also got into the whole, let's create a storyline around dirt. So we started publishing blog posts, which were our media to tell everybody here's an earthquake or the Martians attacking, whatever. I don't know, we made up stories every year. So this time you can tell people are beginning to notice this exercise. The following year, we go to our VP and say, okay, so what do you think of taking down this cluster? It was actually the data center at the time because it was the same thing. But how about we take this down? And he sat there for a second, and then you could see the super evil grin show up on his face saying, yeah, I'll go do that. And I mean, we didn't know what would break. This is the time where Google was in hypergrowth, and I mean, they have been for a long time, but in the early phases where people just throwing software or our systems were just getting launched into wherever there was a machine. There was no index of machines. We didn't know where we were putting what. So we couldn't actually tell you what the impact would be if you brought this thing down. So we spent a lot of time to assess it. There was the forerunners, the big services, search and ads, they were really worried we were going to cause an outage that we didn't know how to recover from because we actually didn't know what was going to cause the outage in the first place. So we did. It was a phenomenal exercise. We brought it down and all that, but I was going to say, that's a huge step forward, still a lot of fighting with the teams and such, and we were not really happy about what we were doing. But here's where we know that we had a bit more excitement in the news media. So we went from newspapers to actually a little radio segment, which is how we launched this exercise. I'm saying there's like popular culture happening in the side while everybody else is opposing us. We need something to have fun with in the war rooms. I'm just saying this is important. But eventually, we got to a point where we started pushing and pushing. Everything started really, this is paper test was the first thing we did. We started pushing further and further till the point that right now, this is what this looks like, right? Let's turn off log savers, let's cut the network, turn off the power, spike the traffic, yeah, let's sip some tea, whatever it is, and do it all at once and see what happens. And you know what? The terrible thing is we're running out of ideas. People are actually able to recover from this at this point, and they'll say things like, come on, you're boring me, find another thing to do. How many times are you going to do the same thing? Well, I really am out of ideas at this point. I don't know what else to do. There's a lot of ways, don't get me wrong. There's lots of ways still, but I just don't know how to execute on them and make this a real thing in production yet without having our entire user base yelling at us. So that's where we sort of, have landed. There are a few pictures over here. This is kind of what our war room looks like. It's generally a lot of people, just lots of machines and stuff. You can tell we did something bad here, and you can tell the graph going straight and up to the right, not in a good way. It's like, I think this was a backlog of something or the other. I can't remember what was going on. I don't know what was going on over here. Someone had a prison suit, and someone at the other room, people are wearing masks. I don't know if any of you were there. I have no idea what was going on there. But you also know that we need sustenance in the war room. This is all normal. This is exactly what dark war rooms look like. So there's candy, there's donuts, and I don't know who played that trick on me, but that's there, whatever that is. So, and finally, I think that all of us have our little evils, right? And for me, my evil is Kit Kat. I don't know, I can't have just one. There's lots and lots have to go into my mouth. So people actually played a trick on this because they created this. And the absolute shameful part of this is I picked every one of those things up on the way into the other room. So, everybody's got one. That's all I got to say about that. Anyway, so we talked a little bit. So it's a fun exercise while it's in the war room. It's very high stress. So you do need a little bit of this as we go along because you are causing outages on a regular basis. So where do we go from here? Must have learned something. We learned a couple of really interesting things, some technical things, some process things. First thing is if you ever want to have a copy of your offline password, type it. Do not write it and think you can ever read your handwriting ever again. It will not happen. We locked ourselves out, I think, a couple of times, but we learned that if you are going to bring down a cluster or data center for the first time, and you have a VP that really loves this exercise, do not leave him near the light switch when you turn down the data center. So that just caused us not to breathe for a little bit. We also learned that there were some really good successful tests. By the way, success to us means that something went wrong. If it didn't go wrong, it's boring. Something has to go wrong, so we learn something so we can fix it. That's what we call success. So by that nature, all of these tests are super successful. The first one, a couple of examples over here, is one on corrupt data. So we had this test where the test proctor actually put in corrupt data into some data store and told the test taker, hey, look, figure out where this is. You have to use whatever tools you've got to tell us where the corrupt data is. So the test taker does this, goes, digs around, finds this corrupt data, and tells the proctor, hey, I found it. And the proctor then says, hey, yes, you did, but that is not the corrupt data I actually put in the system. They found something for real somewhere in there somewhere, so we had to go and fix it, right? But it was a great test for us because we actually found something that had a problem that we had to go and fix. There was this other case where for a very big product of ours, very visible product of ours, we wanted to take down this one test instance that everybody was scared to touch. And that's because it's been there for a long time. We didn't know what was in it, same as the first data center we brought down. So we wanted to take this down, and we did. And immediately we brought down between 30 and 40 front ends belonging to this service. It's a very, very visible service. So I cannot talk into that further. Dear God, that was not good. That was not good at all. So we had to like roll the whole thing back. But we found out a whole bunch of issues immediately. So we were able to fix it. And we know what would happen because eventually we had to turn it down anyway. And I think I had one more no? So this one was great because this test, when we see product latency, this is also a very visible product. And what we ended up doing, see, I'll never tell you guys what this is great. So what we did is we wanted to create a situation where we wanted to have like a serious constraint in network bandwidth that was available to a set of services. And we went and pushed it such that there was such limited bandwidth for the service to function, or a series of services to function, to see how far we can keep pushing this. How narrow can you make that bandwidth is sort of what we were trying to do. And very soon after the test started, we noticed in one of our several monitoring dashboards that the said product actually started flailing. Their latencies were going through the roof. And we really got scared because we couldn't tell if it was us or them, because our tests cause splash effect on many services. It's very hard for us to tell exactly what would happen. So we really, I mean, and the stress in the war room is high. We have a lot of SREs that are sitting there. In fact, a couple walked out because they were really, really upset at, you can't cause an outage. That is not the right thing to do. But the decision you have to make is proceed with the test as intended and be patient, just wait, or roll it all back, but you don't know what will actually happen when you're already that far into the test and you're squeezing out bandwidth. So you wait a little longer, and then we found out that app did it all by themselves. It had nothing to do with us. It was phenomenal, but I'm really glad we didn't roll the test back because we kept going. But it's very possible that we are the people that caused that outage, and I'm really glad we didn't. They pushed a new config or something like that caused them a temporary spike, which is really what had happened. But there were a couple of things that didn't work. So every time you had a thing where a team had to figure out their own service issues, they would just do fine. They would Gmail, figure out everything had to do with Gmail. Docs did everything in Docs, ads did everything in ads. But the part was this. When they actually were in a position where they had to talk to each other, this didn't quite work as intended, which is the whole point of our tests, right? So I'm butchering Mikey's pyramids at the moment because I'm embellishing this a little bit. But we have that in the bottom, which is the kind of the organizational structure. There's several pyramids. Everybody's doing great in their silos. But what we've missed out is, how do we tell anybody what the state of the union is? How do we tell anyone when are we coming back? What is the sequence of services we need to bring up? Should we bring up our local versions of DNS, LDAP, Kerberos first? Should we just like push everybody start installing and figure out what's going to happen? We have no way of communicating between these things. And we have no umbrella team that actually knows what's going on. So if we're out for 8 hours and Larry says, what is going on over here? Nobody has an answer. That was a super failing for us. It was very, very big for us to actually admit to it and actually move from there. So we tried to solve this, and we got involved in a second rung on Mikey's pyramid, which is the incident response ladder. We really wanted to figure out how to make incident response slightly better and more cohesive for these large outages. So we started by creating a central team of like senior SREs or managers or folks who are really good at both the technology and understand the platform and the infrastructure really well, and those who could communicate out really well. So we needed a combination of skills, and their job was basically to tell everybody what was going on. And they had their own, their conference bridge that they would get to if there's an emergency. If everybody got paged, then all hands on deck. So this is for the disaster situation. So when they got to this part, here's a couple of things that we learned. What is a phone number? Why does someone need a phone? Why can't we just IM each other? But we don't have a network, right? That's sort of the assumption. So nobody actually knew how to use a corporate phone and actually dial outside numbers. So we just sat there saying, okay, this is like base case fail, so we had to go and train everybody on this. Second one, once you have 20 people on this phone bridge, not a single person would say hello. They were too scared to talk to each other. So, okay, this is really not going to work. So dead silence. The phone bridge would not say any now. Every now and then there'll be a new person that says, hello, and then that's it, dead silence. Hours of this. There's the first few dirts. It was like, that was the hardest thing for us to solve. The third one, sometimes you have obnoxious people. You actually need to boot from the bridge. I'll give you examples of obnoxious people. The people who want to put us on hold every couple of minutes, but also have hold music to go with the hold. How do you, they don't, I mean, but there's also, like if you're on a conference bridge, there are like 20 different ways to boot people out, and nobody actually knows what these mechanisms are. So they're also, you know, oh no, they'll come back, they're nice about this. So nobody would actually boot anybody out, and that's actually important to do when you're in this mode. And finally, we actually messed up over here. So we created this wonderful layer that was going to figure out what was going on and communicate. Now, how are they going to get information? There's no way, if you look at this picture, how are they going to go after hundreds of services and find out what's going on unless they're in the dirt war room and looking at all the dashboards we are? They have to be in a control room all the time for them to figure this out. So what we actually needed to solve for was this. They themselves needed a pyramid. Mikey is really not going to be happy now, but they needed to monitor what was going on, find a systematic way to get people to escalate to them as the outage reached whatever threshold. And this is new too. So I'm saying, I mean, it sounds like a lot right now, but when it's actually in progress, it's very easy. Hey, Gmail is down. Someone will know about this immediately. Even if we don't say anything, someone external will shout about it. It doesn't seem, it just, in this picture, it seems a little more cluttered than it should be. But we actually needed them to know what was going on across the board and shard amongst themselves. Like you can't have a person know whatever n tens of thousand people in Google are up to. So you needed for them to organize themselves, shard, talk about it, and present regular updates. And if we are saying 30-day outage, 3-day outage in Google, someone needs to give a regular sort of sign as to, hey, what's up, what's down, what's going on, who are we affecting, when are we coming back up? And so that's sort of what we were trying to do. So yes, now what's the problem? We give these people power. They get to see everything that the war room now sees. So we're sitting in this middle room and we have access to all of the outages that are going on because they're all on this conference bridge. We're dialed in and giggling most of the time. But there are all these folks that are really talking about what's going on around them, and it's a very, very amazing place to be. It's like an adrenaline rush the entire time. 3-4 days you'll go there without sleep because you're just riding that wave. It's so much fun. I mean, not in a good way. It's a lot of stress, but it is like something you get addicted to is really what I mean. And so the same thing happened to the incident commanders that are on that same bridge, because they, for the first time, actually get to see the span of what is going on. Every team only sees the part that's affecting them. You know, an app will see the outages that are caused to them, and they're trying to fix it. And they might communicate with the networking guys who have the outage in the first place. There might be some amount of that, but nobody gets to see the global scope of things unless you're in that central bridge. So they get really, really addicted. What happens then? Nobody goes home. They stay on the bridge over and over. Isn't this like basic failure mode? Because you're going to get 10 hours later, 11 hours later, 12, 13, 14, you're cranky. You're making awful decisions, especially if you're responsible for incident command for all of Google's systems. That's a really bad place to be. So we added one more line item in this hierarchy, which is we absolutely need to mandate like a shift system. You cannot have 20 people on the bridge just burning the midnight oil just because it's fun. We actually need for them to go home. And so getting them to the point where they say, like, we're not heroes, we're going to do an actual shift system sort of thing was a huge deal for us to get through. And like I said, none of the other people actually could boot people off the phone. So it was my honor, my great duty to actually go and make people leave. That was horrible. I never want to do that again. But yeah, so this is really where we land. And this is the number of things that we learned from doing this very incrementally over years. So if there's anything, I'd like for you guys to take this and just run with it if you can. But then now here's the problem. We do this, like I said, yearly. It's an annual exercise. Every year for a few days, we go mad, we go nuts, we just have a blast. What happens during the rest of the year? Nobody wants to fix bugs. That's the most boring part of the process, right? So, and we are losing steam in the sense that we don't know what, how, did I just keep going? Someone should have said something. Well, yeah, so we actually didn't know what to test. And there are two things that came out of this. The first thing was the yearly testing is not going to be enough. You want testing to be continuous and try to encourage failure modes to occur all the time, which means it should be part of whatever your system is. If you're releasing software, there should be some sort of failure mode that's constantly built into this software, into your process, into your rollout process. So you're causing failures constantly so that you're always testing the recovery path all the time. If you don't do that, the recovery path never gets tested, so it'll always be a disaster at the time you actually want to test it. I mean, it may not be cost beneficial to do this all the time, but you have to make that decision for yourself. So we wanted to get to that point. I'm not going to dive into that in detail. There's a lot of companies that have done really good literature on this stuff out there. Like Netflix actually has really good models for this. So I'm not really going to cover this in that much detail. But the second thing is, over years, we've generated hundreds and hundreds, thousands of postmortems just from dirt. This doesn't even count the actual postmortems we have from real life incidents. What do we have now? we have a freaking gold mine. We have so much data on the things that have caused us outages, the biggest weak spots that we've got, and yet we are trying to create new things to test. So our biggest problem is we didn't know how to mine this data, right? Everybody writes a postmortem on a whiteboard, on a document. There's no consistent machine-readable format. So we actually had a couple of people sit down and manually just plow through maybe 2,000 to 3,000 postmortems to find sort of general trends. It's fascinating what you would find when you start actually reading through what causes your biggest outages. So you don't have to randomly create tests. You just test and fix the things that are causing you the most number of issues. So I'm pretty sure a lot of us would find a lot of the issues that we have are self-inflicted. Bad configuration pushes, bad binary pushes, bad test infrastructure, bad test integration. There's almost no integration testing in some cases. And so you'll find these sorts of issues that are your hotspots. And if you address these hotspots and you test against them and you start fixing them, you actually don't have to go after hundreds of teams to say, go fix hundreds of bugs, because they're generally going to laugh at you and say, go away, find yourself another person to go nag. They're not going to do it. So if you do this more holistically, and we have created several tracks of work in this manner. We found at some point that how many of you do backups in your systems wherever you are? How many of you have tested that you can recover anything from your backup? So I'm saying that doesn't happen all the time, and if it does, it's a hard process. Like end-to-end recovery is really hard. And we found that that was a weakness for us across the board, and we would try to generate work to make sure that gets addressed. Or incident management is a great example of that. We didn't know how to do it right, and we kept testing until we found the right thing to do. We found if we find issues with the way we do configuration pushes, then we would figure out what the rollout policy should be. So Mikey said something really insightful yesterday. He said that it is not all about root cause analysis, because at some point when your systems get complex enough, there are lots of root causes that for a given error. But there's something that triggers that cause at a later point. So it might be there are several root causes at the bottom, but if you actually push this change to production, that's when it manifests itself. This combination of things is what causes it. So maybe you can check for that while you're in the push process itself. So that's sort of the example that I'd like to draw over here. And so fixing it at the trigger actually works out pretty well. So that's something to take away for us. So we spend an enormous amount of time now on incident response, on postmortems and data analysis from the postmortems, and continuous testing. So just broadly where we go. And yes, if we keep digging, we'll find more. What I mean by this is that recently we found that a lot of people are getting, we found in many cases that people were getting paged and they were doing all these other things right, but they actually had no SLAs or any sort of threshold that they were actually monitoring against. So the monitoring would just go, okay, 90%. I'm going to get paged, or something like that. It was nothing that they're actually committing to. If you don't know what you're monitoring against, what are you actually getting paged against? You have no idea why you're getting paged. You get into ops overload. There's a lot of toil. So this is basic. So this is very, very basic. But a lot of people skip that step because, there are other things that are always on fire or on pressure all the time. So we're in fixed mode. Stepping back for a second to actually assess what your service needs to do and sort of getting to that point is really big. Of course, every time you do this, that evil dude will come back and someone will yell at you. And I know because I get yelled at every week. Why are you making me do this? Is a very constant complaint. But that's okay, because there's also the really, really awesome teams that would say, look, we already know how to do this, but we're going to give whatever you're saying a shot as well. And if it works, it works. If it doesn't, it doesn't. So, and they'll move on. So there's like classes of teams. But basically what I'm saying is all of this is, we did this exercise, but a large part of this is really about some serious amount of culture change. It is not about the testing itself and all of this. It's sort of like getting your organization to a point where they recognize whether it is worthwhile or it's okay to spend as much on outages as on figuring out if there's a better way to deal with them on an ongoing basis, because it's a given that failures will always continue to happen. I think I spoke really quickly, possibly, but I think that's pretty much, oh no, I still have more. Last slide, and then you guys can ask questions. So I wrote these slides in the morning. I told you, it was all Mikey's fault. So the meta things that I would really like for you guys to take away from it. First of all, we learned a lot of these lessons over years of doing what it was that we were doing. And I wish that we had known to think about it holistically right off the bat. I wish we had that, but we didn't. So hoping that there might be some parts of this that might apply to you guys. But the more important things to take away from it is, do not do that. Do not follow a trail of Kit Kats. It'll lead you to a horrible, horrible room. Mikey, we've talked about him a lot. I really owe him a big one because this actually helped us frame our own problem statement much better. This is super important. If you don't test something, you never know if it will work. And if there's anything that we've learned from 10 years of doing this at Google, or intentionally crashing all of our services, it's basically that every time we do it, we sort of get stronger in terms of figuring out, like just exercising the pathways that we wouldn't normally do otherwise. And the last bit I have is, Every one of the things I've talked about did not come easily. None of these things came easily, like from finding sponsors to finding people who are willing to work with you, to finding a team, to actually having the buy-in of our sysadmins. It's not something that happens easily. Like SREs would not buy into this easily. And so it takes a lot of time, but if you hold on to it and get there, actually it is probably one of the most worthwhile investments that we've made so far. And that's all I have, so I have lots of time for questions, I think. I have no idea. Yeah. Perfect, thank you guys. If you have questions, I'm here. No questions? I love presentations like this. Love it. So I'm going to be down for a while and send. Oh, sorry. There's a microphone, I think, or something, right? Yeah. Shut.
It's real short. Some people say you can't test in quality, so your mantra of if you don't test it, you don't know if it works. What's the counter argument to that?
You should say this in the microphone. Sorry.
So a common mantra is you can't test in quality. That quality starts, much more upstream than that. How do you counterbalance your point about if you don't test it, you don't know if it works?
I think that the lower, you have to test at every level of your system is sort of what that actually would boil down to. If you're talking about quality, then quality starts way, way deeper too. So I'm saying that, well, I think I'm talking slightly bit more in terms of if you don't actually exercise the infrastructure layers that you never would touch otherwise, then you're never going to know it'll work. And if it will work, and it won't work at the time you actually try it out. So I think it's slightly different from the product quality aspect that you would be talking about. But I'd say even at the product quality level, you probably are testing at every layer of the stack from start to end, whether it is like from the front end, whether a user tests to see if it works, all the way to whether your infrastructure, the back end works. I think that it sort of has to be continuous and integrated into every part of what you're working on, I think. Hi there. No difficult questions.
No, leading questions. Hi, Kripa. What makes for a good dirt test, and at the same time, what makes for a bad dirt test?
You hit my pet peeve question, because I knew this was going to come. So there are teams that are phenomenal, and they write tests where they know they have infrastructure that they haven't touched before, or they're scared to do this. Well, actually, it started the bad test. So I like to call these teams the pop teams. What I mean by that is that they're like the badasses that chew bubblegum in my face and then pop it and then say, we don't have time for you, just go away. So in order to hit the checkbox when we make them do tests and say that I've actually tested, they would write things like, I think you know the answer to this one, but they would write things like, I'm going to write this test, I'm going to break this tiny thing, this tiny, tiny thing, and it's magically going to create a page. And this page is going to reach that person's pager, and that person's going to act. That's my test. And you look at this, like, isn't this your job? I mean, isn't this normal? So why are we actually testing something that's normal? So that's a bad test to me. Or tests where they're not trying hard enough. It's sort of like, go look at this document and tell me how you can do the steps to recover. That's not what we're going after. If that exists, that you should do that too, so you know your document's current, which never is. But you should be looking at things that are more complex to do, especially in that environment, just because you have the whole company looking at it at the same time. So it's like a perfect place to exploit interfaces with other teams more than things that are relevant to your team alone. And if it's relevant to your team alone, you should be testing all the time anyway. And it should not be something that you wait for said event day.
So in terms of levers to change cultures in the various teams, I understand Google has an interest in metric-related behavior. Do you have any releasable metrics on like faults, pre-dirt and post-dirt, just so that for the rest of us who are interested in doing this, we can take something back other than Netflix and Google do it, it must be awesome.
I don't actually know numbers off the top of my head, and I don't know how much of these I can talk about, but I'll give you examples of things that might be useful. I hope they're okay to say. Let me go with this. When I mentioned that the first cluster, the corp cluster, the first data center that we took down, it actually, I hope this is okay, it never came back up. So we took it down, it just went. And then over a period of time, the senior leads for some subset of services at the time they came to the war room, and at some point you would actually see some of them with their head in their hands saying, "This is embarrassing, turn off the test." And we actually didn't know how, because we had messed up something so badly. Like, I think I don't remember exactly what happened at the time, and so we actually could not recover from it. The second year, we actually did not recover from it. The third year, we came up to, in 8 hours, we were able to go from end to end, I think. The year after that, it was 4 hours. Now nobody even notices that it's gone. So I'm saying, I would have liked to have done that a bit faster, but I might have burned out a lot of people very quickly. But that's an example of something that we did test, and it took us better and better time. But broadly speaking, in terms of health-wise, I mean, I don't know off the top of my head. We haven't done some sort of consolidated thing. We do it in pieces, right? So if we say that form of test did so much better from then to now, or I don't have numbers for this, but in places where we have actually implemented some serious incident management, we know that the amount of time it takes from the time you discover an event to the time you fix it has gotten significantly shorter and shorter and shorter. So that's another thing. So, but I actually don't know the numbers off the top of my head, and it's very hard to generalize across Google. It'll be per service sort of thing. I hope that helps.
Hi, you were talking about the culture change. The whole project, was it from top to bottom, or bottom to top, or mid-level up?
It was mostly bottom to top, but we did have a rock-solid VP sponsor. So what that means is that when we had a lot of conflict initially, you had to go debate him to get an exemption from whatever it is that you were being asked to do. So he would debate you, and if you can say there's a real valid reason, he would say, yeah, you're out, that's fine, you don't have to do it. But until that point, you actually had to go and face him, and he was like Ben Traynor as our VP, and he was phenomenal in that. It really helps to have someone have your back when you go through something like this. But everything else was basically designed from the ground up.
I think you may have already answered this question previously, but revenue impact. So these kind of activities do cause business and revenue impact. How did you justify that to the higher ups?
So I think that the way we went about this is you can have the same outage happen either when the whole company is watching or when no one is. So the revenue impact in the latter would probably be way higher because people have to fumble to figure out what's going on versus when we cause it. When we cause it, we know how to roll it back. So if someone says there's a problem, it'll take us a minute to pull, hopefully, to pull the thing back, or up to a couple of minutes to pull it back. But if no one knew this was going to happen and it happened for real outside, it generally takes a very, very long time to recover. So it's the relative revenue impact of when we do it first and figure it out so it doesn't happen again versus when we actually see it for real outside. I'd also say that this is not a cheap exercise, obviously, if you have hundreds of people doing this. But the point of it is that over a period of time, it's not so much that they're investing time in the exercise, it's so much that they are sort of implementing the principles of the exercise in their own design process. It sort of goes to like, you actually design testing and quality in deeper into the stack. So if you look at this long term, it's a very, very useful exercise to do. It's not so much about I spent 3 days in this whole year getting all the engineers to do something else. We also do 3 days in offsites, right? So it's the same thing, but it has more long-lasting impact is how I'd place that.
What kind of process and documentation do you have leading up to these dirt tests? And when you look at how your rollback works, how deep do you go into your rollback documentation?
For every single test that we do, so this is hundreds of tests that we're talking about for each year. I mean, we do a lot more now. It's a lot more continuous now than it used to be. But for each given test, there's a given test template where you are actually required to write every single thing down, what you expect to have happen, what you expect to see, what is the fallback if it doesn't work out, what the impact will be if it works, if it doesn't. So all of the risks are laid out completely. And there is a technical team that actually reviews every single one of these. Even the one that says, here, I page someone, act my page, even that test gets reviewed by someone because we know that there might be a shot at this. So that's about, and then there's a site that tells everybody how to play the game, like essentially what the logistics of the day, but not much more than that. Most people end up fixing their own documentation as part of the exercise because they know the test is coming. So it's a perfect time for them to just clear everything in it. Anything else? All right. Thank you so much, folks. Bye.